First presentation discusses developing clean natural gas engines, and our presenter is Thomas Hodek, Program Leader of Natural Gas Engines at Cummins Westport. Tom is responsible for the development and production readiness for new natural gas products and has helped deliver 3 new natural gas engine platforms to the North American on-highway market, the most recent being the ISLG, which meets the CARB-optional low NOx standard of 0.02 grams per brake horsepower hour. If you're not familiar with Cummins Westport, they are, it's fair to say, we try to always split things down the middle. They are the dominant manufacturer, particularly of mobile gas engines in North America. And I'm sure Tom will work very hard to make sure that that continues. Tom's in his 31st year with Cummins, and he's a Purdue graduate with a bachelor's degree in mechanical engineering. Let's welcome Tom.
Good afternoon, everyone. Thanks for joining me today, and I want to thank Integer Research for having us here today. We got a good story to tell, and I'm going to kind of walk you through our journey to near zero emissions, 0.02 grams of NOx here. And so I put a few slides together. I'll walk through them. I'd like to change up the venue just a hair. If you have any questions when I'm on a particular slide, just don't hesitate to raise your hand. I've got a clock here, and I got to push start. There we go. And it's counting me down. So I'll try to stay on track. And I thought I'd give you a couple of slides first about who we are and kind of what we're doing. If you don't know about Cummins Westport, you may have heard about Cummins in the diesel engine business. You may have heard about Westport in the fuel systems business. We got together and made a joint venture, and we're in almost, I think, 4 more years to go until the JV reaches the end, at which point in time we can either re-up or Cummins will take over the product. But the slide on the screen here shows you the sandbox we play in. We've got 3 products for North America. So we're from 6 liters to 12 liters and EPA North America on highway only. Okay, we have developed some Euro 5 and Euro 6 products through the Cummins part of the joint venture, and we're trying to crack some markets in Europe right now. But for the most part, we're on highway. And you can see this is a little bit of a dated slide. It looks like 2015. We've exceeded 90,000 units in sales cumulatively so far. So if you wind the clock back, you know, Cummins is pretty much as a diesel engine manufacturer, and we knew back in the 80s when they started regulating emissions that there was a deadline for diesel. And it was going to get tougher and tougher as emissions got more stringent. Yet when we stacked all the programs we wanted to work on and drew the line on the budget for the year, natural gas was always below the line. So we really struggled getting natural gas off the launch pad. And it really wasn't until Westport joined us and they said, we've got some ideas too. Let's join forces 50-50 and let's develop some products. So that's kind of what we've been doing since about 2000. Back in 2012, we renegotiated our contract with Westport and we're moving on to 2021. The 3 products we're offering here, the first one we came out was with the ISLG back in 2007. And back then, the industry was at 2 grams brake horsepower hour of emissions. That was the standard back in 07. And we came out at 0.2 grams. So this was an emissions play. Okay, we're 10 times lower than the standard. And then after that, the cost of fuel started to rise. Oil prices took off, and all of a sudden, the cost of the fuel was a big deal. At the same time, they lowered the emission standards in 2010 to 0.2 grams, where we are today. So the emissions play went away, but the cost of operation was there. Okay, and now the fuel prices have come back down, and now we're dropping our emissions levels down to 0.02. So we're back to where we were in 07, where we're more of an emissions play right now than a payback on the fuel play. But if prices go up again on diesel, we'll have both of those in our hands. We'll have both the emissions and the cost of ownership. Okay, so we don't play too much in the smaller segments. We're probably about class 5, 6 for the B, class 6, 7, maybe 8 for the L, and class 8 for the X. Those are our 3 product lines. The good news about the product is that they're 80% compatible with our diesel counterparts. So we started off with the diesel engine. We changed the cylinder head, put an ignition system on it. All the controls are different after treatment and so forth. But it's 80% the same. So that allows us to run these engines in serial line down the same assembly lines as the diesel folks in all of our plants where we manufacture these engines. Pretty close to the same ratings. Natural gas doesn't go as high in power or torque as the diesel counterparts, but then we also have a lower operating cost on the fuel side of this. So it's a nip and tuck thing right now as to which technology is better. And now EVs coming into play and fuel cells are there. They're all great technologies. I'm not going to knock any of them. But our natural gas stuff right now is starting to get down to the point where it's affordable, it's available through the OEMs, and it's also the cleanest emissions. Another big piece of this, and you'll get a lot of guys demonstrating technologies, and they can get down in the weeds on emissions, but can they produce it, and then can they support it once it's producible? And that's one of the things. Cummins has a pretty established network in North America, and is really growing around the world to service the product. It's one thing to have the technology, but it's another to have it producible and serviceable by the end user. So as I mentioned, after treatment is different. I'll get into that later. We have an ignition system. We have spark plugs, whereas diesel doesn't. They just compress the air and it gets hot enough and fires off. Diesel's using a waste-gated turbo these days for emissions reasons. We just have a VG turbo. We're just using a waste-gated turbo on natural gas, so it's a little less costly in that regard. And then the maintenance requirements are fairly similar, and we're always working with folks like Lubrizol on new technologies to extend maintenance intervals and so forth. So a lot of good stuff, a lot of commonality between the products, and we'll go into next year with a whole new line of products, and I'll get to that in a minute. So the question is, why near zero, and why did you guys do near zero? And Cummins has a policy. It's a kind of written policy at Cummins that will always produce products that are as good as we can do on emissions. All right, we never could do emissions on our own, and I'll get to that in a minute, but we found a way to do it, and because we found a way to do it, we did it. And the things the regulators are trying to get out of the air that come out of the tailpipe, the constituents of emissions, we have greenhouse gas, we have NOx, or oxides of nitrogen, NOx, and we have particulate matter. Those are the three constituents that the regulators would just as soon be gone. And we're trying to get us there. Those three bars on the left show the blue bar is the transportation sector. So anything with wheels going down the road is what we're putting into the air collectively as an industry. So greenhouse gas are about 45%, oxides of nitrogen were about 83%, and then particulate matter were almost all of it. Okay, and that's mostly diesel PM. Natural gas doesn't really have PM. There's very little carbon in the fuel. And then on top of that, you hear all about Southern California being a non-attainment zone, but there are an awful lot of other places in the country that are non-attainment zones, and those seem to be increasing in number over the years as they become more and more aware of the smog in their cities. So we thought there might be a business case on this as well as just demonstrating the technology. If we could produce this, maybe we might have something to sell. So that's where we are. California came back to us. ARB said, we said 0.2 was the limit, and everybody agreed, and the engine manufacturers pretty much said after 0.2, it's going to be really, really tough to justify a business case to invest that much more money in incremental technology to get below this already low standard. So California tells us that even if everybody was at 0.2 grams in the Southern Basin area, it would still be a non-attainment zone. So they said that's not good enough. The 0.2 is not good enough. And therefore, we're going to put out optional low NOx standards, and they basically cut the standard in half each time. They went to 0.1, 0.05, and then 0.02. Optional standards, okay? So we picked that last one, and we said, we think we can do this, but we need some help. It's expensive, and it's always falling below the line in our AOP roll-up, and we don't think we can reach the pedals, but we think we can do this. And so I've got a special thanks slide. Anybody here from ARB or SoCalGas or California Energy Commission? Doesn't matter. These guys helped us. These guys said, if you can demonstrate this technology, we're in. We want to get this out there. We need to clean up the air. So South Coast AQMD, CEC, and SoCalGas and Air Resources Board have all been involved either financially or regulatorily or whatever. They've been promoting us and incentivizing us to move this down the path. And that's what we've done so far. So the money we receive from these agencies, there are three levels of, I'll call it evolution at Cummins. We have PPT, which is product preceding technology. This is where all the scientists live, all the PhDs and all the guys that are just super brainy. They're looking at new technologies, and they're trying to figure out a way to make it kind of a real technology. If it's just a breadboard design or something you can do in a test cell once, that's what they do, but they also try to make it something they could put on the shelf and say, you can use this technology, you guys. And then the VPI, that's where I am, the Value Package Introduction Group. we go to the shelf that they have and we'll look for technologies that they've developed and put on the shelf. And then we go through a very rigorous process, and we're almost there on our 2018 product. We got 1 month left, where we'll validate these technologies and get them ready for production. And then we hand them over to the production guys. That's the manufacturing plants. And that's when we're finished developing the product, and there's some overlap between all three of these phases. But once it's in production and it's working, then we're closing the program, and it's totally current product. So the regulators and agencies have helped us in the PPT arena. What we thought would turn into a demonstration became very, very real, and we took it to the VPI level. In 2016, I'm sure you can all read this, but these are copies of our executive orders from ARB and EPA for the first near zero or ultra low NOx engine certified in North America. I took an opportunity here. I'm not sure if you can read it yet, but what I'm trying to point out is in the NOx category. See if I can push the right button here. Yeah, so right here in NOx, the standard is 0.02, and this is the FTP and the SCT cycles, and there's a not to exceed NTE of 0.03. We came in at 0.01 and 0.004 for SCT. Now, we rounded up to 0.01. It was actually 0.0078. So we could, if they had another optional lower standard, we could probably certify to that as well. But it's 0.02, and we're happy to be there. Okay, so we're there with the ISLG today, and in 2018, we're going to kind of change the name a little bit, and we'll be there with a number of other products at the same level as well. And that's just NOx. If you look at the greenhouse gas piece of this, the standard is 555 grams. We're down here at 465. Okay, and that is, if you include the methane over here, we're a bit off on that one. We're still working on misfire and things like that, where you still get methane. We'd be at 0.475, I believe, which is still way below the standard. In fact, I think the Phase 2 standard numbers are out, and we're already compliant with these products for the Phase 2 standards coming in 21, 23, and 27. So we're ahead of the game in that regard. Okay, so anybody seen this slide before? I like this slide because this kind of graphically indicates what we just did in terms of vehicles. In 1958, that's when they first started regulating emissions. Okay, we were probably up in the 12-gram arena with all the black smoke pouring out. They said you got to be at 10.8 grams in 1985, and that's what we did. And then there have been a number of subsequent changes in emission standards. I couldn't list them all here, it'd be off the side of the page. In reducing those emissions constituents down to 0.2 grams, or it's where we are in 2010. Okay, so moving the ball down here, that is the same as 54 vehicles in 1985. So the amount of the exhaust coming out the tailpipe back in 1985 is the same amount you'll see out of 54 vehicles today. That's just spectacular. I mean, the industry's done a good job in reducing NOx, PM, and greenhouse gas over the last 20 years. But if you go to near zero, so I'm going to push it one more time, if you go down to 0.02, it's worth that many vehicles. So we've only gone, it looks like a very small number, from 0.2 to 0.02, but it's a 10-time reduction in NOx. So it's 540 vehicles versus the one vehicle back in 1985. And I get a little bit bold here, and I say we actually certified to 0.01. So you can disregard the slide after this, because there is no 0.01 standard. But if there was, we'd certify to it, and you again would double it again. So you'd have 1,080 vehicles collectively putting out the same emissions as one bus did back in 1985. Now, that's just huge. I mean, the money we've spent as an industry, the regulators have been on us. They've done for the right reasons. We've cleaned up the air. And this is a testimony to where we are today. And if you look at the highlighted area, that's where we are today across the board with the 0.2 gram standard. But this shows you where we would go with the near zero technology if we were to implement it fully. Okay, so it's kind of a cool, funny slide, but it kind of represents in scale what the difference is in emissions since we started doing this, since 1985. And I can include diesel in here, and I can include EV and everybody. We're just doing a good job in cleaning up the environment right now. It's good. So moving ahead to 2018, we're branding our engines different. Cummins also did the same thing, so we had to follow suit. Happened to be timely. In 2018, we will be required to be onboard diagnostics compatible. So OBD is part of us now. Diesel guys did it back a few years back, and we learned a lot from them. Lights coming on when they shouldn't come on, and unhappy customers because the light's on, or lights coming on so often the driver disregards them, or high warranty because the truck's always in the shop getting a light turned off. There's a lot of work to be done on OBD, and we've learned a lot from those guys. But when you throw near zero into it and natural gas systems, it gets even more complicated. So I don't want to go too much into the weeds on OBD, but it's a big darn deal that we've got this certification coming. So we'll have the 12-liter, the X12N will be certified to 0.02 grams next year. The L9N, which used to be the ISLG, will become, it still is, but it'll be only near zero, so 0.02. And the 6.7 liter we just launched in 2016, we launched it at 0.1 gram. It has the same architecture as the other two, so we could do it, but we're out of bucks. So if there's a large demand and we can justify a business case, we'll take it down to 0.02 as well. But in 2018, all three of our products will be below the standard, will be optional standard certified for 2018. And we're also taking the same opportunity, not just to do the OBD and the near zero NOx, but there are a number of mechanical improvements we're doing on the engines from current product today. There's a litany of things we're changing, and it's just becoming same as diesel or better. That's kind of our mantra at Cummins Westport. And so far, so good. I mean, the field testing is really looking good on these products right now. And leadership at Cummins and at Westport is giving us a lot of scrutiny on this, because when you go to near zero, you're kind of opening the doors to anybody come and challenge you on what you've done. And it's not just certifying at the front end, it's certifying at end of useful life. Any time in the life of the vehicle, they want to pull those three vehicles over here and test them, we've got to do that. And it's not just under the FTP or the SET cycle. They want us to test it in real world, as I've been hearing this morning, real world kind of numbers. And we've done that. In fact, we launched the near zero product. We said we were going to launch it in March last year, but we didn't. We held up because we found a better technology on catalyst coatings. It was much, much more robust over the life of the after treatment. So we held off for 6 months, put some prototypes out there, did our field testing, all of our requirements fulfilled, and found out that it actually worked. That's been rolled forward into the 2018 product across the board. And now we're feeling really good about the robustness of the products. I really don't want to go into the slide. Go next door, talk to Carl from Volvo. He's talking about OBD right now, but this is a layer of complexity that I just can't even put a dent in. This tells the engine has to monitor every component in the emissions system through sensors and virtual sensors and so forth. And if anything ever gets out of whack or fails, it turns the light on, and you've got to go fix it. Okay, it's kind of the watchdog on the engine to make sure you're still compliant with emissions. And that is a very, very, very complicated process we've had to go through, but we've done that. We've submitted to ARB and EPA our OBD certifications back in August of this year, as well as our emissions. And so hopefully before the end of the year, we get those executive orders back and we can go to production. I can't tell you the details here, but it is involving many subsystems on the engine. It's a spark-ignited technology, so our piston bowl geometry is critical. We have EGR on these engines, but we don't use it for the same reasons. The diesel guys use it. They use it for NOx control. We use it for knock control, not NOx, knock. And if we have pre-detonation, if the combustion charge fires before you want it to, that's bad. That puts a lot of undue pressure on the engine. So we use the EGR to dilute the natural gas going in to control the knock when we need it, not for emissions reasons. Closed crankcase ventilation is something you're going to see on every one of our engines in 2018. And we've got it on the B already and the L already for near zero, but everything's going to have it going forward because that's a source of emissions. If you have a breather vent out the side of the block that vents the atmosphere, any gases that get around the piston rings into the crankcase go to the atmosphere eventually. So we take all that blow-by gas, we filter it, we put the solids back into the oil pan and the clean air back into the turbocharger. It's a closed system. So that's going to be something unique for 2018. And then again, our catalyst, this is kind of where, from a price perspective, a diesel engine is probably less expensive, natural gas is more expensive, but the after-treatment system on a diesel engine it's definitely more expensive than what we put on a natural gas engine because all we use is a passive throughway catalyst on ours. And we've had to go with a bigger catalyst because we're trying to capture more NOx and more of the constituents of exhaust and convert those. But it's still a passive, no controls on this unit. It had a couple of sensors on it for oxygen and temperature, and that's it. And then the holy grail here is really what's inside the ECM. We have a new ECM for 2018, and that's where all the special sauce is. That's where we control all these systems together to make them achieve near zero emissions. And they've got to do that in a way that is robust, but also adaptable, because things change on an engine, and the controls have to change with it. And we figured out some ways to do that right now, and it's really, in all of our field testing, which is it's pretty stringent, it's looking pretty good right now. As far as the end user goes, we were concerned, they would be concerned about fuel economy, because natural gas engines don't get the same fuel economy as a diesel. There's not the same heating value in natural gas as there is diesel. They're inherently 10 to 12 to 15% less fuel efficient. So you burn that much more fuel in a diesel gallon equivalent, but the fuel is also less expensive. So the more miles you run, the more fuel you burn, you start getting a payback on the fuel a lot faster. If you don't run many miles, it's hard to pencil that one out. But if you burn any fuel at all, it doesn't take long to pay back on the investment. So what I just said, though, was from a system perspective, the engine and the diesel and the natural gas systems are almost equivalent. But then on the vehicle, there's a differentiation, and that is a diesel fuel tank is basically an aluminum or steel tank, whereas on a natural gas truck, it's a carbon fiber, valves, piping, sensors, all kinds of stuff. And that's kind of where the differential in price at the truck level comes in. Okay, and I know that there are a lot of guys working hard on this and trying to get that cost down, but that's probably the biggest payback you got to pencil out on your cost of ownership model. Fuel economy is not changed when we go to near zero. Drivability has not changed. It's all the same ratings, same peak torques, same idle speeds. Everything is identical to current product. Durability continues to be a main focus. A lot of those improvements I just showed you on a previous slide are actually improving the durability over today's products. So getting closer to diesel, like to pass them up. All the same base warranties and extended coverages stay in place, just as they were yesterday and today. And then maintenance, the only thing we're really adding to that is this the CCV system I talked about, the closed crankcase ventilation system. It's got about a 2,000 hour change interval on the filter head. So we'll be launching these things. We have our certifications coming, we hope. We're working with the regulators every day on that. They have a lot of questions, especially on OBD. Did you really do that, set that threshold monitor correctly? And what about this and what about that? And so it's 24/7 right now with these guys, getting them comfortable that our submission is accurate. And we'll get our executive orders here hopefully before December. So the B and the L will be built at the Rocky Mountain Engine Plant in North Carolina. They're ready to go. And then the ISX 12N will come from Jamestown Engine Plant in New York, and they're ready to go. So we're just waiting for our emissions certificates, and then we'll be converting all of our products over. Yeah, so moving ahead, we're all going to near zero on all three platforms. The B to follow, be the last one. And one thing I didn't mention here was we are liquid natural gas, compressed natural gas, and renewable natural gas compatible. It's all methane-based fuel. It's all the same kind of a fuel. But if you use renewable natural gas, the agencies like that, because natural gas comes out of landfills and cows and everywhere else, and its damaging effect on the ozone is 25 times worse than carbon dioxide. So if you can use that natural gas, the methane coming out of the landfills or out of cows or wherever else, restaurant waste, whatever, put it into a digester and get the natural gas out of it, and you can use that. Rather than that going into the atmosphere, you're converting it to CO2, which is a lot less damaging. So you get this environmental benefit when you are RNG compatible. We don't use it to certify to, it doesn't matter to us, but just in the big picture as you operate vehicles, if you can use RNG, and a lot of people are catching on to this now, a lot of the refuse guys are actually running their trucks for free because they're taking methane off of the landfill, scrubbing it, and putting it right into their trucks. You know, and now they're starting to sell back to the pipeline. There's a lot of things happening in California where that RNG, they get a credit for that when they put it in the pipe. And we're completely compatible with all three of those fuels. Any questions? I think I'm done here. Yes, sir.
What do you see as the most, we know you've done a really good job in terms technology, in your heart of hearts, what would you like it to be?
Well, so we cover everything from the question, if you couldn't hear it, the question was, what would the prime market be if we could choose? Did I get that right? Paraphrase. All three of those engines have a platform they're good for. We're already big into refuse. We're already big into transit bus. And that's our biggest volume, but the biggest volume is really in Class 8 truck. With a 12-liter engine, we go up to 400 horsepower and 1,450 foot-pounds of torque. It's not record-setting performance as far as hauling 80,000 pounds across the country. But for a regional guy, or in the port of LA, or somebody that's going out and back the same day, that's perfect. And there's an awful lot of low-hanging fruit right there with a 12-liter engine we could pick up, provided they could pencil out the cost. That's where I would like to go with it. On the other side of the B, things like school bus. School buses are interesting because they want them dirt cheap, but they want the highest technology because you're hauling the most precious cargo on the planet, and they won't put up for anything less. So we've had a lot of adoption of natural gas in school bus right now, but then propane's also in there, and they've got some very low cost engines in that market as well, some conversions. So both ends of the spectrum have a lot of potential for us, but I think the single most, the biggest impact we could have is, if you look at that NOx slide I showed, the particulate matter, is mostly Class 8 trucks. And if we could get more Class 8 trucks with natural gas in them, especially at low NOx levels, that would be the biggest impact for the environment. Yes, sir.
Question. In these Class 8 trucks
Yes.
with a natural gas engine, what is the maximum range you can achieve?
It depends how many diesel gallon equivalent gallons of natural gas you want to put on. They have, typically behind the cab, they have stacks of cylinders behind the cab. We've seen 300-gallon diesel equivalents behind the cab. They also have saddle tanks now that look very similar to diesel tanks, but they're quite expensive. You could make the range work. That's not the issue. In fact, the weight difference is not that bad compared to diesel with these additional tanks. You got to look at your back of cab to front of trailer kind of space and your overall truck length in some states. There are some limitations, but as far as range goes, I don't think natural gas has an issue with the range. I think the bigger issue has been the infrastructure. Can I pull over anywhere I want and get natural gas? And that has been, clean energy has been very instrumental in funding refueling stations across the country. And they're making some good headway right now. You can go coast to coast pretty easily on compressed natural gas. If you go with liquefied natural gas, you get a lot more range. I mean, it's liquefied, so it's almost like diesel fuel, but it's very, very complicated process. And that stuff also vents off. It reaches a certain temperature and pressure, you got to get rid of it. And that's methane overboard kind of a thing. So they're all good technologies and they're all good fuel systems. You get the best range out of liquid natural gas, but you can put enough compressed natural gas on these days to make it pretty much coast to coast. Mm-hmm. Sure. Any other questions? All right. Well, thanks for your time today. One in the back. Yes, sir.
Yes. Have you made volume projections for how many you will sell?
Yeah, we have, but I can't share that. Just like I can't share the pricing information. We do see growth, definite growth by 2021 when this joint venture ends. And Cummins conceivably at that point in time would take it back inside its walls, and they would continue those projections outside. I got to be careful with all this stuff. And we didn't exactly get a pat on the back from the industry when we went to near zero emissions. I mean, that's put the pressure on a lot of other people. Here we are. This is not a demo. This is production, and it puts us in a tough spot where, if you're a regulator and you've got 3 engine platforms that do the job you want, why is it not being used? That's a tough spot. We did this for the right reasons, and we're not pushing it to sell it over diesel or anybody else. But it's thought provoking on where do we go now, And then you got EV coming down the pipe. There's a lot of inertia behind electric vehicles. It's a great time to be in the emissions business. I mean, there's so much going on, and something's going to happen. I hope they all succeed, frankly. Each technology has its niche, and we'll see where it goes. But volume's going to be what it's going to be. We show increases year after year for all three platforms for the next 5 years. That's about all. I can't give you the specific numbers, though. Ben, I think we're done here. All right, thank you.